All right, so yesterday's entire section was just based on the Pythagorean theorem, right? So we talked about what the Pythagorean theorem is, and then we did a couple of triples, and then we did how to apply the Pythagorean theorem, which number one would be something like this. This is just your right triangle. You've got to find the length of the hypotenuse by doing 15 squared plus 36 squared equals x squared. What's 15 squared? 225. What's 36 squared?
1,296.
Good. And then I'm going to add those two together. And then square root. Obviously not a perfect square we know off the top of our heads, right? So we're going to break this down using our factor tree. So 2 obviously doesn't go into it. But so let's see if 3 does. 1 plus 5 is 6. Plus 2 is 8, plus 1 is 9. If when you sum the digits of that number, they add up to a number that's a multiple of 3, then we know it's divisible by 3, right? Yeah. So I know this number is divisible by 3. 1,521 would be 3, and then 507. Those digits also add up to a number that's a multiple of 3, it'd be 12. So this is 3, 120 would be 6. 27 would be 9. 169 is what? Perfect square, 13 times 13. So then for each pair of these same numbers, 1 goes to the outside of the radical. There's a 3 that comes out. There's a 13 that comes out. And then there's nothing left underneath. We multiply those together, and I get 39. So now we know 1,521 is 39 squared, but obviously that's not a perfect square. I expect you to know.
That's a pattern also.
That's one of the triples. Mm-hmm. There's like so many triples, it's crazy. But any time that you have all whole numbers on your sides, those are all triples. Okay, that's not as common as the other ones. I think in your book, I need to look, but somebody said that in your book there's like it took the initial ones and scaled them up so you can see multiple ones. All right, number 2 says find the area of the isosceles triangle. So first of all, it's important that this is isosceles because why? What happens in an isosceles triangle? Good. The altitude cuts the base in half. So this is 24 and 24. And then what we're missing is the height. So I need area, which eventually is 1/2 base times height. But to get there, I have the base. I have the 48. I need the height. So I've got another right triangle. Which of the sides needs to go by itself? The 51, good. So I'd get 8 squared plus 24 squared equals 51 squared. And then I would get 8 squared plus, what's 24 squared? Yep. How about 51 squared? I actually don't know this one off the top of my head. I want to have to do the work.
2,601.
Thank you. And then subtract. And then square root. So if you know it, you can do it. If not, I know this ends in a 5, right? So 5, 4, 0, 5, 5, 81, 9, and 9. You can keep going with those 9s, but if I know I have a repeated 9, I know it's going to come to the outside anyways. It would end up being 2 3s, which would be the same. But there's 1. There's the other. So I get 45. That's the height, though. That's not the answer to the question. Now I have to do 1/2 48 times 45. So I can either multiply the 48 and the 45 and then divide by 2, but I'm going to get a much larger number. Or I can cut that 48 in half. So if I did that, I get 24 times 45. And it gave me a unit this time, so it's centimeters squared. Good. Questions? Okay. Be careful. Like, the initial concept is something you know and should be relatively simple, but all that work, there's so much room for error. Like, as Mateo pointed out, it's very annoying work, right? But it is work that you know how to do. You just need to be careful and make sure you don't make mistakes along the way. All right, number 3, find the unknown side lengths and write your answer in simplest radical form. So I've got 2 right triangles happening, okay? The one on the right, the big one is not a right triangle, but I do have a right triangle here. And I have a right triangle here. I have to use one to get to the other. So what can you do first?
The left one is a common triple.
Good. What would be the height of this?
8.
Good. 6, 8, 10 is one of those triples. And then is there an 8, 12 one? No. So we got to figure it out. 8 squared plus 12 squared would equal x squared. 64, 144. And then square root it. Yep. That's one of your triples, 6, 8, 10. If you don't know it, then you got to do the Pythagorean theorem for the first triangle. 6 squared plus whatever variable you want to make that. B squared equals 10 squared, and you'll get 8. That's fine. It's just extra work. So then this is 2, 104, 2, 52, 2, 26, 2, 13, and then there's one pair of 2's, a second pair of 2's, and a single 13, which is going to stay underneath the radical. Good.
Why did you, for the first one, why did you keep the 3 on the outside?
All right, so this is 28 from the homework. It said solve for x if the length of the 2 legs of a right triangle are 2, so if we wanted to draw it, 2x and 2x plus 4, and the length of the hypotenuse is 4x minus 4. So if it's a right triangle, then 2x squared plus 2x plus 4 squared would equal 4x minus 4 squared. So the first one, you can just multiply out, like distribute and multiply, or multiply and distribute, doesn't matter. It'd be 4x squared. But the next 2, you've got to FOIL out.
Yeah.
That's when all the fun happens. So this is 4x squared. This would be 4x squared plus 8x plus 8x plus 16. Or 4x squared plus 16x plus 16. This is 16x squared minus 16x minus 16x plus 16. Or 16x squared minus 32 plus 16. So then combine the terms on the 8 on the right side and the left side. This would be 8x squared plus 16x plus 16 equals 16x squared minus 32x plus 16.
Please pardon the interruption.
So for me, as soon as I see an x squared and an x, I know I'm going to end up having to factor. I'm going to get everything to one side. So I'm going to move the 16x to the right. I get 0 equals 8x squared minus 48x. And actually, these cancel, right?
Yeah.
So then how do I factor 8x squared minus 48x? What can you take out of there? It's the greatest common factor of 8x squared and 48x. X is one of them, but what else?
2.
Bigger. Keep going. 8, right? 8. 8x, and I'd get x minus 6. So force back to Algebra 1 skills, right? If you have 2 things that multiply together to give you a 0, then if either of them are 0, then the whole thing is 0. So we split and solve, and I get x equals 8, 0 divided 8, which is 0, and x equals 6. The reason why it only gives you 6 is what happens if I make that x 0. Can you have a side length that's 0? No. If I plug it in here, I get a negative. Can't have a side length that's negative. So we rule out the 0 and we keep just the 6.
What did you do about that?
Oh, okay.
What did you do about that?
Say that again.
After you factor.
So after we factor it and you get to this point, there's 2 factors here. But if either of this factor, so like if this was 0, then the whole thing is 0.
Yeah.
And if this is 0, then the whole thing is 0. So we split it and solve it.
Okay.
Set them each equal to 0 and solve. Normally, if it was just like an algebraic equation, there'd be 2 answers. But because this is geometric and we're saying that these represent side lengths, you can't keep the 0. You can't have a side length that's 0. So you get rid of the 0 and you keep the 6.
How did you get to the point where x equals 0?
Divide both sides by 8. So this part comes over here, right? This is 0 equals 8x. This is x minus 6 equals 0. And I get x equals 0 because I divide by 8. And add the 6. So a little forced algebra review, right? All right, 7.2 is the converse of the Pythagorean theorem, which is taking everything we talked about yesterday and reversing it, okay? So remember, converse changes the if and the then, right? The converse, or the initial one, said if it's a right triangle, then a squared plus b squared equals c squared. So what would the converse of that say?
If it's
This is right triangle.
Whoa. Yes.
What was that?
I think he said, if a squared plus b squared equals c squared, then it's a right triangle. And if that's what he said super fast, that's correct. Okay? That's the converse of your Pythagorean theorem. If the square of the longest side of the triangle, that's your c squared, is equal to the sum of the squares of the other two sides, that's your a squared and your b squared, then the triangle is a right triangle.
I thought he cast a spell on us.
So again, if a squared plus b squared equals c squared, then the triangle is a right triangle. Now we're working the opposite direction. Okay, here's some additional triples. So we talked about the ones yesterday. We even added one of these. But we talked about 3, 4, 5. We talked about 6, 8, 10. 5, 12, 13. And then we actually added on 8, 15, 17. But here's some additional ones as well. 10, 24, 26, which is what happens if you multiply 5, 12, 13 by 2. 9, 12. All right. 9, 12, 15, which is what you get if you multiply the 3, 4, 5 times 3. 12, 16, 20, which is by 4. 15, 20, 25. So some of these, again.
6, 8, 10, you can multiply by 2 and you get them.
Yes. Oh, but there's two. That's two ways. Yep. Because 6, 8, this is times 2, right?
Mm-hmm.
That's times 3. I mean, there's a lot of different ways to get to these, right?
Are you recording?
Yeah. Is that okay? All right, so this kind of takes off of the Pythagorean theorem converse. Not only do we know the relationship of the sides if it equals, but then there's two. Theorem 7.4 says if the square of the longest side of the triangle is less than the sum of the squares of the other two sides, then the triangle is an acute triangle. So if you write it in the order in which the C comes first, I think it helps to make sense because you're saying it's less than. If it's less than, it sounds like it should be acute. That's why we kind of reverse the order. So what do you think happens if c squared is greater than? It's obtuse. Yeah, you guys could have led this lesson today. If the square of the longest side of the triangle is greater than the sum of the squares of the other two sides, then the triangle is an obtuse triangle. So equals, right, if c is less than, acute, if c is greater than, obtuse. All right, so example 1 says the sides of a triangle have the lengths given. Is the triangle acute, right, or obtuse? A lot of times the instructions will also say, what if there's no triangle? So remember that before you even get started, you want to check to see if it's even possible for the side lengths to make a triangle. What's the rule about that?
20 plus 29.
Good. So the two smaller sides have to add up to be bigger than the third side, right? So you want to check that first because sometimes it's just not even a triangle to begin with. So 20 plus 21 is bigger than 29, which means now I've got to go through the work of seeing if it's right, obtuse or acute. So I'm going to say 29 squared has what relationship to 20 squared plus 21 squared? So 29 times 29, we go back to multiplying everything out. $841 has what relationship to, this would be 400, and 21 times 21, 441. Good, which means what?
Right.
Good. So the next one, first you want to check to make sure it works. 20 plus 21 is bigger than 30. So we're saying 30 squared has what relationship to 20 squared plus 21 squared? 30 squared is what? 900. We already know what 20 squared plus 21 squared is, right?
Yeah.
So what's the relationship this time?
Obtuse.
It's greater than, so it's obtuse. Good so far?
Yeah.
All right, so then I get 2, 5, 6, and 8. Is that a triangle?
Yes.
Yes, right?
Yes, that's
So 8 squared has what relationship to 5 squared plus 6 squared? 64, 25, 36.
64 is greater than 60.
Good. Which means this one is also obtuse. Okay, then I get to D. So before I even get to figuring out what kind it is, I have to figure out if it is a triangle. For these, you want to approximate a radical. So root 3 is in between what two perfect squares? 3 is in between what two perfect squares? 1 and 4, which would be 1 in between 1 and 2, yes?
Mm-hmm.
Is it closer to 1 or 4?
4.
Closer to 4, which means I'm going to approximate this to be like a 1.8, right? We're just kind of approximating so that we know if 4 times 1.8 plus 4 is bigger than 8. Is 4 times 1.8 plus 4 going to be bigger than 8?
Yes.
Do I even have to go through all that work?
No.
No, okay, because I know 4 plus 4 would be bigger than 8. Yes, you with me?
Yeah.
So I know it's a triangle. Now I'm going to say 8 squared has what relationship to 4 squared plus 4 root 3 squared? And 64, 16. This becomes 16 times 3, or 48. What's the relationship there? Good. So they don't have to be a triple for them to be a right triangle. And the last one, 1 plus 3. What would root 10 be in between? You could do it. What perfect squares is 10 in between? 9 and 16. Yes? Okay, a little bigger than 9, which means this is approximately like a 3.1-ish. Yes?
Yeah.
So does 1 plus 3 bigger than 3.1? Yes. Yeah, 4 would be bigger than 3.1. Yeah? Okay. Why is it 9 and 16? So you're looking for perfect squares, right? 10, which is what's underneath the square root, lies in between 9 and 6. You need perfect squares. And the square root of 9 would be 3, and the square root of 16 would be 4, which means the square root of 10 is in between these two, which would be, and close to 9, which is like it's 3.1, 3.2. You could say any of those things.
So you don't care if it's like.
It doesn't have to be perfect. It's a total approximation. Yep.
So I can put like 3.9.
be perfect for it to be a right triangle.
That's Chris was.
This is not determining what kind of triangle it is. This is determining if it is a triangle. Now I got to figure out what kind of triangle it is. So in order to do that, I need to know, is root 10 the biggest of those three numbers, right? And we just said it's like 3.1 or 3.2, so I know it's the biggest, right? So I'm going to put that as the C, because that has to be the biggest. The one by itself has to be the biggest. Now, what happens if I had messed that order up? Once I square everything, it should still be in the order of biggest to smallest. So if you're confused on the square roots, like figuring out how big they are, once you square it and get rid of it, you should see the order should be correct. Does that make sense?
Yeah.
The biggest one should still be on the outside. So does 10 equal 10? Yes. This is a right triangle as well.
You squared it.
I squared it, right? Square root of 10 squared. That's a 2. Becomes 10. Camilla.
So you would square like the one for D for root 3. You would do you would square the 4 and then multiply it by the root.
So for me, I square them by distributing. I do 4 squared, and then I do square root 3 squared, which is 16 times 3. The other way to look at it is this is 4 root 3 times 4 root 3. It's still 4 times 4, which is 16. root 3 times root 3, which is 3. You could look at it either way. Questions? This is just everything we talked about in one screen, okay? So you're classifying a triangle using one of these 3 sides. You're going to figure out the longest side is always first. If it's equal to the sum of the other 2 squares, then it's right. So equal is right. If C is less than, it's acute. And if C is greater than, it's obtuse. But we're always going to check to make sure it's a triangle first, okay? Because if you go through all that work and then your answer is really no triangle, it stinks. You lose all those points, okay? So always check to see if it's a triangle first. Check to see if A plus B is greater than C before you even start. Questions? Okay.